families. This is Mrs. Craig again today, and this time I'm coming to you with a strategy session for the division strategies and vocabulary that we've been using in our classroom. Before we start, I wanted to go over a little bit of vocabulary. This is my dividend, and the way that I help students remember it is that it's on the end. It represents my total that I'm dividing. This number here is my divisor. And it represents either the number of groups that I have or the number inside the groups. And here my number sign is a number sign, not a hashtag. Finally, we have our answer to a division problem, which is the quotient. And the quotient can either be the number inside a group or the number of groups. Now, as you can see, these two things here are interchangeable. And so whichever one we have here, the quotient is the opposite. Now, this only matters when we're talking about word problems. So, for example, I could have 22 students, and I want to put them into groups of 4. How many groups will I have? How many groups can I make? Okay, or conversely, I could say that I have 22 students and I want to divide them amongst 3 different groups. So if I divided them into 3 different groups, how many students would be in each group? Okay, so in this particular case, if I'm dividing them into groups of 4, then I'm looking at this particular question scenario because I'm looking at, I know that I have 4 inside the group. How many groups do I need? But in this problem, I'm dividing them into 3 groups because my known is the number of groups and my unknown is how many are in each group. So that's just a very simple kind of explanation of what each one of these things means. We also know that we write our numbers like this. So here, this is still the dividend. And I kind of make the point that it's sort of on the end side. So dividend sounds like end, it's on the inside. Here's my divisor. And this is where my quotient will be. Okay, so if I'm doing the traditional algorithm, I think it was 4019 divided by 3. One of the things that students initially have trouble with is they have trouble remembering the order of the steps. And so we think about them in terms of an acronym. And I know that this is kind of a silly sort of thing to remember, but dirty monkeys smell bad, right? And the reason that we come up with this funny little saying is because it helps us remember the order of the steps. So dirty means that we divide because divide starts with D. Our next step is to multiply because multiply starts with an M. Our next step is to subtract. Subtract starts with an S. Our next step is to bring down. And our last step would be the remainder. So it looks like this. Our first step is to divide 4 divided by 3. And I know that all of you know this, so I'm going to go really quickly through it. 4 divided by 3 is one group of 3. That's my division. I kind of try to help them remember that we're multiplying for our next step, and we multiply 1 times the divisor here. So this is part of our quotient, and we're multiplying that times the divisor. So 1 times 3. And then our next step is to subtract, and our next step is to bring down. Now, oftentimes, if we have additional numbers here, we skip the remainder step until the very end, and we go up here to repeat the steps. So now I have 10 divided by 3. That's my division. So I have 3 groups. 3 times 3 is 9. Subtract. 10 minus 9 is 1. We bring down again. And a lot of my students are having trouble bringing down and lining it up exactly. That's why I make them draw the arrow initially. So we have 11 divided by 3 is another 3 groups, and 3 times 3 is 9. 11 minus 9 is 2. And they bring down. So now I have 29 divided by 3, and that's going to be 9 groups. 9 times 3 is 27. 29 minus 27 is 2. I make sure that they check to make sure that this number is smaller than my divisor, because if this number is bigger than my divisor, then I haven't divided out enough groups. Since it is smaller than my divisor and I have nothing else to bring down, then this becomes my remainder. So my quotient is 1,339 with a remainder of 2. I know that you know this and you remember being taught this in school. However, students, this is the last step that we get to. So before we start using this, we give them some alternate strategies. And I wanted to show you those alternate strategies. So if your student comes home doing something that you don't recognize, you can say, oh, okay, now I see what you're doing. So this is the end goal of what we're looking for. But one of the first things that we did was we used an area model. So if I have 4,000 divided by 4,019 divided by 3, I'm going to take it and split it up into pieces. So here I have 3 is my divisor, so it's still going to go here. And I know that 3 times 1,000 is 3,000. Okay, so now I have 4,019. I've dealt with 3,000 of it. I still need 1,019. So I might say that 300 times 3 is 900. And so now I've dealt with 1,009. I had 1,019. I've now dealt with 900 of those. Now I have 119 left. Okay, so maybe I deal with another 30 groups, and 30 times 3 is 90. So now I have 29 left. And I know that 9 times 3 is 27. And I have 2 as a remainder. So my quotient is 1,000 plus 300 plus 30 plus 9 with a remainder of 2, which is 1,339 remainder 2. So this involves breaking it up into smaller chunks and sectioning off those chunks. It's a little bit more tedious, but if they're comfortable with the area model of multiplication, they might like this model here for division. Okay, they just need to remember that anything left over, so when I had 29 and I subtracted 27, I have 2 that I can't fit evenly into a whole nother group, so that this becomes my remainder. Okay, so that's another method. But then we have this method here. And here I'm going to make it a little bit wider. This is where my ones place is going to be. This is where my tens place is going to be. This is my thousands and my hundreds. So I know that I have 1, 2, 3, 4, 5, 6, 7, 8, 9 dots because I have 9 ones. I know that I have 110 because I'm still using the same problem. I have 0 hundreds, so I'm not going to draw any dots there. And I have 4 thousands. 1, 2, 3, 4 in the thousands place. Now I also know that I'm going to be dividing into 3 groups. So here I have, I'm going to put, this is going to be one group. This is going to be a second group. And this is going to be a third group. Okay, so I'm going to take these dots here and I'm going to see, okay, so we start on this side because in a division problem, we start with the largest place value. If I were multiplying 4,019 times 3, we would start with the ones column. But since we're dividing, we start with the thousands column. So I'm going to take these 4 dots and I'm going to divide them up into the groups. So I have 1 dot here, 1 dot here, and 1 dot here. Now I have 1 dot left, but I can't put it here because the important thing about division is that we're talking about equal groups. Since if I put it here, I would have nothing in this box and this box, I need to regroup. And so I know that 1,000 is the same as 10 hundreds. So I'm going to take this 1,000 and make 10 hundreds out of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So now I'm going to start doing the same thing that I did before. I'm going to take these 3 and put 1 in each group. Then I'm going to take this one and this one and this one and put 1 in each group. And then I'm going to take 1, 2, 3, these 3 and put 1 in each group. So now I have 3 hundreds in each group and I have 100 left over. Well, I know that 100 can't be split evenly amongst these groups, so I'm going to have to regroup this one as well. I'm going to shift it over into the tens place because I know that 100 is the same as 10 tens. Now I already had 110 in my box, so now I have 11 tens, and I'm going to do the exact same thing that I did before. I'm going to take these 3 and put 1 inside each box. I'm going to take this one plus these 2 and put 1 inside each box. I'm going to take these 3 and put 1 inside each box. And now I have 2 10s left over. Well, this is going to involve drawing a lot of dots, but I can do it. I had 9 dots already. I'm going to take these 2 10s and I'm going to put them here into my ones place because 2 10s is the same as 21. So I need to make 20 dots. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Okay, so now I have 29 dots inside the ones column. So I'm going to start dividing them up into groups and into 3 groups. So I'm going to take these 3 and cross them off. And here's 1, 2, 3. I'm going to take these 3 and cross them off. 1, 2, 3. These 3 can go. These 3 can go. These 3 can go. This is another group. 1, 2, 3. Okay, so we have 1, 2, 3. And we have, oops, I left one out. We have 1, 2, 3. 1, 2, 3. And then I have this one that I left out, and I have this one left out, so that's my remainder of 2. So I know that those cannot be split into these 3 groups because if I put 1 here and 1 here, I would not have an equal one for that group. So this is my remainder of 2. And my quotient, now I'm looking at how much is in each group. So I have 1,000. I have 1, 2, 300s. I have 1, 2, 3 10s. And I have 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. With the remainder of 2, which equals 1,339 with a remainder of 2. Okay, so this does involve a lot of drawing of dots. So while it is helpful to show students the remainder and the regrouping, this is not ideal. So we moved on from this introductory strategy to the next strategy that I want to show you. And this one looks a little bit more like the traditional algorithm. So I have 4 thousands, 0, 100, 110, 9 ones, and I'm dividing it by 3. Okay, so I want to divide 4 by 3. I have 1,000. Okay, so I'm going to take 1 times 3 and I'm going to subtract 3. 4 minus 3 is 1. This is what I like about this method, because in the traditional algorithm, when we bring down the 0, they don't necessarily know what they're doing. So what I like about this method is that it shows you that 1,000 is equivalent to 10 hundredths because I put it in the hundreds place. So I move my 1,000 and I create a 10 hundredths because I put a 1 in the tens place. So now I'm going to divide 10 by 3, which is exactly what you do over here, 10 divided by 3. And I have 3 groups. 3 times 3 is 9. And I subtract 9, so 10 minus 9 is 1. And in the traditional algorithm, I would bring down that 1 to show that I have 11 tens. Here, instead of bringing it down, I put it up here where I have 10 tens plus 1 10 equals 11 tens. So this was 100 is equivalent to 10 tens. So now I'm looking at 11 tens divided by 3. And I still have 3 tens. 3 times 3 is 9. Oops, I need to catch myself up. So here I have a remainder of 2, and I would be bringing down the 9 ones. Here I'm looking at 2 tens. Well, 2 tens is the same as 20 ones. If I have my 20 ones, I can add them to the 9 ones that I already have. So now I have 29 ones. So I'm still going to divide 29 divided by 3. 9 times 3 is 27. 29 minus 27 is 2. This is still smaller than 3, so that's still my remainder. So I like this strategy because it really shows you the equivalencies, that 1,000 is the same as 10 hundredths. 100 is the same as 10 hundredths plus the one that was already there gives me 11 tens. 2 tens left over is the same as 20 ones plus the 9 ones. So I like this strategy because in my mind, it actually does a better job of explaining what's going on here when you're bringing stuff down. So I hope that's helpful. If you have any questions, you're always free to email me or your child's teacher if it's somebody else watching the video. Thanks so much.